The robots aren't just coming, guys. They've actually been here for a really long time. In this explainer, we are diving deep into the fascinating journey of robotics. We're going to explore how a centuries-old dream of mechanical servants evolved into the decentralized, autonomous swarms and the side-by-side workplace reality that we see today. It is honestly an incredible story of engineering, philosophy, and collective intelligence.
Okay, let's start with a genuinely staggering thought from Aristotle, all the way back in 322 BC. Can you imagine? He pictured a future where intelligent automata could actually abolish human servitude. He imagined a world where an instrument could just do its own work, either at a word of command or even by intelligent anticipation. It really goes to show that the concept of automated helpers isn't just a byproduct of the Industrial Revolution, it is deeply, almost unimaginably, embedded in the ancient human imagination.
So what actually is a robot today? Basically, it's a bridge between computer science and the physical world. Fundamentally, robotics is a field focused on developing computer-controlled machines. These systems are explicitly designed to mimic human motor activities, handling dangerous, repetitive, or super-precise tasks. And they do it 24/7 in our households, our factories, and even in totally hazardous environments.
Here is our roadmap for this explainer. First, defining AI and robotics. Second, a history of mechanical men. Third, the power of swarms. Fourth, cobots and new safety standards. And finally, the labor market impact.
Section 1. Defining AI and robotics. Let's take a look at physical AI in the real world.
Right now, physical AI basically falls into three main buckets. You've got your industrial robots, handling the heavy lifting and welding on massive assembly lines. Then you have mobile robots, acting as transport or even being used by the military to do things like disarm explosives. And finally, humanoid robots. These look and behave a lot like us, acting as ushers or shop attendants. Now, they bring massive advantages. I mean, they don't take leave, they don't demand pay, but as we'll get into a bit later, they also spark some very real concerns about job displacement.
Moving on to Section 2, a history of mechanical men, taking us from myth to reality.
This timeline absolutely blew my mind. From the polymath Ctesibius building steam and hydraulic automata way back in 285 BC, to Susong's incredible cosmic engine clock tower in China around 1088 CE. And get this, in 1206, an Arab engineer named Al-Jazari built an actual programmable automated waitress that could serve drinks. By 1495, Leonardo da Vinci was sketching detailed inner workings for Mechanical Knight. We humans have literally always been obsessed with engineering artificial life.
Fast forward to the 20th century and things really kick into high gear. In 1920, the Czech writer Karl Čapek officially coined the term robot. Then the milestones just started stacking up. Konrad Zuse built a programmable computer in 1939, and William Gray Walter created these autonomous light-seeking tortoises in 1948. But the massive turning point, 1961, George Davil's Unimate, which was the first digitally operated programmable industrial robot, was officially deployed at a General Motors assembly line. That moment permanently changed modern industry.
Section 3, the power of swarms and the magic of collective intelligence.
So instead of programming one massive, easily breakable robot, engineers started looking closely at nature. Particle swarm optimization literally mimics how flocks of birds forage, which turns out to be perfect for mapping and search tasks. And ant colony optimization? It mimics how ants leave pheromone trails for pathfinding. It's a huge paradigm shift from centralized control to a decentralized, totally fault-tolerant robotic collective.
But for this collective intelligence to actually work, these swarms have to talk to each other. They can use direct communication, your standard wireless protocols like radio or Bluetooth, but the really wild method is indirect communication, also known as stigmergy. This is where robots actually modify their shared environment using virtual markers or digital pheromones, leaving a collective memory for the other robots to follow. It operates exactly like a real-life ant colony, leaving a chemical trail behind.
The real-world applications here are massive. Picture a search and rescue scenario. If one robot gets crushed in an unstable building, the swarm just routes around it and keeps locating survivors. We're talking monitoring complex ecosystems, automating planting and precision agriculture, dynamically sorting inventory in giant warehouses, and eventually using medical nanobots to target drug delivery directly inside the human body. I know it sounds like sci-fi, but this collective intelligence is going to be growing our food and delivering our medicine.
Section 4. Cobots and new safety standards, specifically looking at ISO 102118-2025.
Okay, so when robots and humans start intimately sharing the exact same workspace, regulation obviously has to catch up. The big philosophical shift with the newly unified ISO 10218-2025 standard is that cobots are no longer treated as this separate, magically safe category of machine. The rule now dictates that safety relies entirely on the collaborative application. It's not about the robot itself anymore. It's about exactly how that robot is being used in a specific environment.
To actually comply with these rigorous new rules, integrators have to follow a really strict active sequence. First up, identify hazards. And we mean everything, not just collisions, but the tooling and manual handling too. Second, estimate the risk severity and likelihood. Third, implement physical reductions, like limiting power and force. Fourth, validate those safeguards through actual physical pressure testing. And fifth, document every single step to create a bulletproof, traceable audit trail.
This expanded standard introduces some pretty critical updates, too. Cybersecurity is a huge new focus now. I mean, you definitely don't want a hacked network being able to remotely disable a life-saving physical safeguard, right? They've also added enhanced guidelines for end-of-arm tooling. Because let's face it, if your robot is holding a sharp piece of metal, it doesn't matter how slowly it's moving, it is a severe physical hazard. So mandatory pressure testing and strict speed and separation limits are now firmly enforced to keep human workers safe.
And finally, Section 5, the labor market impact and the economic consequences.
To really wrap your head around the sheer scale of this industrial shift, just look at this number, 742,500. Way back in the year 2000, which is wild to think about, the United Nations estimated there were already 742,500 industrial robots operating globally, with more than half of them in Japan alone. Today, that number has skyrocketed exponentially. They are permanently baked into the very fabric of global production.
Now, this explosion of tech brings incredible productivity, massive flexibility, and way better workplace safety. But it is for sure a double-edged sword. It causes a very uneven labor market impact. On one side, it creates these amazing efficiencies and entirely new, highly skilled engineering fields. But on the flip side, it actively displaces certain types of manual jobs, which means the global workforce is having to learn entirely new sets of skills on the fly. So I'm going to leave you with this final provocative thought to chew on. As our ancient dream of mechanical helpers, that same dream shared by Aristotle and Da Vinci, becomes our everyday side-by-side reality, how are we going to adapt? Will we elevate our own human potential and thrive alongside our new mechanical coworkers, or will we struggle to find our place in the swarm? Thanks for hanging out with me for this explainer. It's been awesome exploring this with you, and I will catch you in the next one.